Welcome to a video on bivariate data. So today one of our focus is going to be on correlation. So when we look at linear correlation, that's when we plot dots in a scatter plot and they tend to look like a line. So if it's a straight line, well, we can create a formula for that, but we're going to have a look at line of best fits. So a line that best fits the scatter plot or the scattered dots that are on your axis. Pearson's correlation represents the linear correlation, and it can range from -1 to 1, and it'll be represented by the letter R. So if it's a positive correlation, it has a positive gradient. So as one variable increases, the other variable also increases. And a negative correlation represents a negative gradient. So it's a bit like our straight lines that we've done in the past. And with your negative correlation, as one variable decreases, the other increases. So a +1 correlation is a perfect positive. That means all the dots are in a row and it's in a positive gradient or a positive slope. And if it's a -1, that's a perfect negative correlation. So here's a couple of examples. So there's an example of a perfect positive where R equals 1. You can see all the dots are in a row. If R equals 0.98, so it's pretty close to a straight line, but there's some variation. But you can tell it's definitely positive and it's very high correlation between the two variables. And a weak positive, so this one you can just tell it's actually in a positive direction. But the R value, so the Pearson's correlation, 0.3. We're going to have a look later at how you work that out on a calculator. Here's our negatives. So the perfect negative is -1. So all the dots are in a slope in a negative direction. So negative gradient, and they're all in a straight line. Negative 0.98. So negative slope, but not perfect, but pretty close. And weak negative is -0.3. So you can just tell that it's negative. And here's an example of a zero correlation. So it's not positive or negative. You can't distinguish. So therefore it's a zero correlation. Hence it goes from -1 to 1, the Pearson's correlation. When we look at a nonlinear, that's where the dots tend to vaguely represent a curve, such as your cubics, your exponential parabolas. The line of best fit is a regression line, or known as a regression line, is a line that you draw by eye through the scatter plot. You try to get it to pass through as many points as possible. And the equation of the line, since it's a straight line, we can use y minus y1 equals mx minus x1. So this is an example of a line of best fit. You can see that in this case it would be a positive slope, so positive correlation. It would probably be around 0.6 or 0.7, because you can tell it's positive. There's no sort of outliers, but generally everything sort of correlates. Passes through 2 points, so we can use those 2 points to find the equation of the line. So firstly we find the gradient. That's our normal way to find the equation of a line. So you just do y2 minus y1 over x2 minus x1. So the gradient's 9/25. Subbing that in and expanding, you get y equals 9/25 x plus 22/25 as our equation. Just a little bit extra in regards to this, 2 words that might come up. Interpolation is when you look at your data, so your scatter plot, and hence the line of best fit. Interpolation is when you're finding a value that's within the existing data, so you can actually use your line of best fit. Extrapolation is where you estimate a value that is outside the data. So you're trying to predict something either larger or smaller than the data that you're being given. So that's the end of this one. Thank you.